Hi guys, welcome back to the next lesson on the percentage chapter. And this lesson we are talking about another application of the PCG. The last couple of lessons I'm sure you have gone through the percentage, the product change applications of the PCG. And this lesson I'm talking about the product constancy application of the PCG. I'm talking about the product constancy application of the PCG. And this applies in a lot of questions directly, and there's a lot of implications of this which you should understand. What is product constancy first of all? Let's say you are given a situation where the price of a commodity has gone up by 25%. The price of a commodity has gone up by 25%, and you are asked to reduce the consumption such that the expenditure remains constant. Price have gone up by 25%, consumption has to come down such that the expenditure remains constant. Now this is a slightly different situation from what you saw in the product change situation. In the product change situation, what happened was the price change was given, the consumption change was given, you were asked the percentage change in the expenditure. In this case, what they are doing is they are fixing the expenditure to remain constant. So now the thinking in this question is that since price into consumption is equal to expenditure, and the price is going up by 25%, we do not know what's happening to consumption, but we do know that the expenditure has to be constant, which means that if I start with 100 as my original expenditure, after two changes, the change on price and the change on consumption, my expenditure should be back at 100. And so since we know what has to be put on the price arrow, we can put that here, and 100 is increasing to 125 because of price. So what is happening on consumption, how much percentage drop you need on consumption, will be visible to you from this part of the picture. And you're using structure 1 of the PCG here. There's a drop of 25 on 125, which means the drop is 20%. So 25% increase in price is offset by 20% decrease in consumption to keep the expenditure constant. Price was increased by 25%, consumption needs to be dropped by 20%, and this is the answer to the question which had asked us, how much do I need to drop consumption so that my expenditure remains constant? Right, so this is the PCG applied to product constancy. And essentially what you do for product constancy is, after the series of changes, you need to come back to 100. So if I tell you that the price or the length of a cuboid has gone up by 20%, the breadth of the cuboid has gone up by 50%, how much should you reduce the height by to keep the volume constant? Just listen to this language and isolate this language into your head. If you want the volume constant, it means since the volume is the product of length into breadth into height, so if I put my starting product volume as 100 and the ending volume also as 100, my product has to be constant. I'll need 3 arrows, one for L, one for B, and one for H. The L arrow will have a 20% increment. The B arrow has a 50% increment. So I can see my volume changing from 100 to 120 and then 120 to 180, because this will be a plus 60. So my height arrow, how much do I need to drop height by, will be seen from 180 to 100, which is essentially a drop of 80 on 180, which is nothing but the ratio of 4 by 9, which is 44.44% drop, right? So 4 by 9, 1 by 9 is 11.11, so 4 by 9 is 44.44% drop. And that reminds me to talk to you about a little bit about developing some standard fractions and their percentages in your head. So I hope you've understood this part. So let's move on to what I wanted to say. So what in that problem, what I did was, when I saw that 4 by 9, I got that 44.44. That comes from the logic or the knowledge that 1 by 9 is 11.11%. And if 1 by 9 is 11.11, 2 by 9 is 22.22, and 3 by 9 is 33.33, and 4 by 9 is 44.44, and 5 by 9 is 55.55, and 6 by 9 is 66.66, and 7 by 9 is 77.77, and 8 by 9 is 88.88, and of course 9 by 9 is 100%. So you will see this kind of structuring or this kind of values. Once you get to know 1 by 9, you can actually know this table, and there is a lot of value in solving problems on percentages. So there are other denominators, of course, apart from 9. For example, the denominator 8, 1 by 8 gives us 12.5. So you should be able to recite the table of 12.5 till 100 as 12.5, 25, 37.5, 50, 62.5, 75, 87.5 and 100. So 8 as a denominator, 9 as a denominator, and then there are a few more denominators that you should know by heart. 11 as a denominator gives you 9.09. So the products of 9.09, 2 by 9, 3 by 9, 4 by 9, 5 by 9, and so on till 1 by 11, 2 by 11, 3 by 11, 4 by 11, 5 by 11, up to 11 by 11. This is the list of products. So you need to internalize these denominators, and that will add a lot of value to your thinking. Please do explore the denominators 12, 3, 4, 5, 6, 7. I've already told you 8, 9, 12. So please do explore these denominators and the standard percentage values like this. And you should know each of these denominators and their standard percentage values. It should be internalized as part of your aptitude prep for cons. Right, so I'll get back to you with that. I want to wind up this lesson. I'll get back to you in the next lesson with the next issue that we want to take up in this course or in this chapter of percentage. Right, bye for now.